Hi, I'm Adrian Cull, founder of the Live Forever Club, and I'm going to give a quick presentation on my recent trip to the Longevity Med Summit. So this was held just outside of Lisbon at the beginning of May 2023, and it was over 2 days with over 30 speakers, so a lot to cram in, and more than I have time to include in this highlight. So I'm just going to kind of make some interesting points about talks and presentations which I found interesting. I've grouped them into 4 main topic areas: longevity clinics, aging clocks, interventions, and aging research. There were plenty of other talks in other areas such as longevity investments by Jim Mellon and Maxim Friedrich-Mieterdau, which I haven't got time to go into, unfortunately. So on longevity clinics, interesting to see that clinicians are really starting to push for true health care rather than sick care. So progressing from treating symptoms to curing illness and even preventing illness, which I obviously, as founder of the Live Forever Club, hope to see that preventing illness will eventually result in preventing aging. There were a few private clinics being represented at the summit, which are for people more wealthy than probably most of the club's members, including myself. But most things start somewhere. They will be pushing some of the technology, pushing some of the ideas, ready to go into public hospitals. And there were 3 people there doing just that. In China, Israel, and the US, there are hospitals starting to have longevity clinics. Also, interestingly, I bumped into a doctor from Ukraine. He'd had to get a special pass to leave the country for a few weeks. And he said even there in Ukraine, where things are bad with the war, they are still thinking of going ahead with longevity clinics in their hospitals. One of the main speakers, and actually we see her in a couple of areas in this presentation, was Andrea Maier from the National University of Singapore. She is setting up a clinic in the Alexandra Hospital, set to open in August, with the aim of extending Singaporeans' health span by 3 years within the next decade. So a pretty good target, which is kind of half cheating, given that certainly in the UK, lifespan has been increasing by 1.5 years every decade for the last 4 decades. In the early part, that was actually faster, but it's slowed down recently. But great if you can double how fast we are increasing our health span and lifespan, more the better. We then had Evelyne Bischof talking about AI-enforced individualized medicine, optimizing the individual peak performance by identifying, restoring, and maintaining optimal biological age. And she is from Jiatong University in Shanghai, and at the summit she announced that she was also going to become director of the Sheba Medical Center in Israel. But coming back to what she was saying about maintaining optimal biological age, with my glass half full, I'll certainly say that, well, optimal biological age is not getting more and more frail, is not your biological age getting so old that you're more susceptible to diseases. So I'm certainly hoping that long term, optimal biological age means stopping biological age and stopping aging entirely. She had an interesting slide. Probably won't be able to see the detail on the video, but it was about all the different things which you can measure in the human body, the function of the human body, well, not all of them, but lots of them, and how they decline with age. So these bars are showing as percentages the percentage of function at age 75 compared to 20 to 45 years. So young, the sort of age where if rejuvenation treatments come about, then in your 20s, in your 30s, physically you're feeling pretty good. And we can see why you're feeling good then compared to in your 70s, because brain level, whole body level, nerve impulses are only functioning at 90%, so everything's running 10% slower. Blood supply to the brain has dropped 20%. Blood supply to the kidney, 50%, so your kidneys aren't working as well. Your brain mass is almost halved. Number of taste buds is down to a third of what they were, so you're not going to be able to taste things as well. And right at the bottom, you've got rate of recovery of blood pH to normal. Not too sure what the clinical implications of that is, but you can see that's only running at 17% of what it was when you were in your 20s and 30s. So a lot of things in the body really degrade with age, with biological age. There's also a presentation by James Raff at Biolytica, demonstrating, well, one of the things he demonstrated was the platform that they're using to analyse lots of data. And this was probably one of the key things I found at the summit, and it's not something particularly wrong with the summit, was that there was a lot of things we could diagnose or measure. So, doing a lot of omics, a lot of different clocks, a lot of things we can measure, but what you can actually do is still very limited. A clinician I spoke to in one of the coffee breaks said, well, having taken all this data, and I think this ran it through some nice clever algorithm to say, well, maybe what you should be, the treatment pathway should be. This doctor, she said that, well, that's probably would have been first or second guess, even without all that data. So I think we've got a lot of data, still haven't got as many treatment options to really have precision medicine or personalised medicine to react to that data for the individual. And I just mentioned lots of clocks. Joanna Bent she's the founder of the Longevity Centre. They have a few clinics in Germany, Poland and Switzerland, and listed all these clocks. So glycan age, I'm going to talk about that briefly later, telomere age, cognitive age, cardio age. And it made me think, well, at some point, are these just measuring the function and the health of individual organs rather than the age? I think they can only really measure the age of an organ if that organ declines with age, which most of them do. So I guess you can maybe measure the age of an organ. Okay, second section I wanted to talk about was aging clocks. So I mean, there are lots out there. I've tested lots myself. I've blogged about several epigenetic age clocks. Just done the recent one from Clock Foundation, which uses GrimAge. I've also done glycan age as well. I use youth.ai, which is that you can upload your blood panels to, and it'll give you a blood age. You can have face ages and lots of different ways of measuring what your biological age or your kind of healthy age compared to average is. And at this summit, there's a few more mentioned as well, a few new ones coming, and I'm sure we'll see plenty more. Before I go into the individual clocks which came up, this is a good definition of what a good biomarker of aging, and therefore what a good clock is, from Eric Verdin. He is the president of the Buck Institute, and he rightly pointed out that to be a biomarker of aging or an aging clock, it's got to reflect an underlying age-related process. It's got to be down at the cellular, subcellular level and work across tissues and across organs, so not just something which is organ-specific. It's got to be able to predict your health span or lifespan and respond to interventions. And this is what we want, this is what we're trying to have, biomarkers of aging, when we are testing these early rejuvenation treatments. We can't wait to see how people are faring in 20, 30 years' time. Did they die in 30 years or 40 years or 50 years' time? We want to be able to see in a couple of months, couple of years, was there a big impact on their health and their biological age, and we're going to use biomarkers to do that. The clock which Eric Verdin mentioned was based on CD8 T lymphocytes, part of the immune system. And he is modelling, creating a new model based on 84,000 CPGs. But this was an interesting chart which showed that he's got a clock which is based on all CD8 T lymphocytes, but even if you go down to the subgroups, because these immune cells, they start off as naive, become central memory cells, then effector memory cells, and you can look at those different subgroups of these CD8s. And they also, you can actually do a clock for those individual subgroups as well as the supergroup at the same time. We had Gordon Lauk, he's at many of the conferences, and I don't blame him, he's still trying to raise awareness of glycans, which are carbohydrates, which cover all cells and all proteins in the body, and therefore must be a really important part of cellular communication and protein interactions. But you rarely see this in most, lots of the textbooks and models around how proteins are interacting. The glycan profile on your blood cells is what determines your blood group, so that's a good indication of just how important what these glycans look like, how important it is to your biochemistry. So he's done a lot of that from the University of Zagreb. He's also Chief Scientific Officer at Glycan Age, and we have a biological age clock. And he presented, one of the many slides he presented was interesting, that looking at the glycans, it indicated risk of cardiovascular disease independent of clinical risk factors. So if you've done your bloods and your heart's looking okay, looking at your glycans might still give you an earlier warning that your heart is not aging as well as it should. And that kind of reminded me of a saying, I'm not sure if it's totally true, but the most common presentation of cardiac arrest is death, because in many cases there is no early warning. So you may have not had any clinical signs. So if this is another way of maybe getting that early warning, so you can start treating a diseased heart, then that would be great. I had another clock. This was from João Pedro de Magalhães. He's now at the University of Birmingham. And his paper, I think, was not looking at individual CPGs, or not specific CPGs. So lots of the clocks are looking at hundreds in the original Steve Horvath clock, to now thousands of CPG sites, and kind of analyse the pattern of methylation at those individual sites, or those groups of sites. I think his clock was more to say, well, you can look at the whole epigenome and look at the noise, and you can base your clock purely on the noise, which kind of makes sense. It's just overall how much damage has occurred anywhere in the epigenome. Maybe that's a good way of predicting age. However, I think he was saying this is predicting chronological age, which of course we know a chronological age, but knowing your chronological age may be useful when you are working across species, and this clock works not just in humans but in other animal models as well. Back to Andrea Maier, she, as part of her talk, she was also talking about clocks and aging clocks. And she produced this diagram, which was really interesting, I thought, about how different organs age different rates. So some organs are going to start aging before others, and there's a general system interaction or kind of order that organs age. The one she highlighted as an example was the fact that these have arrows on them, so they are working in different orders. And the main point she made was, so the pulmonary age, so if the age of your lungs is more advanced than your chronological age, then it's likely that your heart will age afterwards as well. So that means clinically, if someone's got lung damage, you should also be starting to look at their heart and maybe looking at early treatments there. But you can see the arrow is only in one direction. So if your heart is aging faster than the rest of the body, that doesn't necessarily mean that your lungs will be. And that was an interesting kind of flow of aging between the organs. Okay, so interventions. There were no kind of major rejuvenation treatments presented at the conference. The ones I'm going to go through were all supplements, which realistically at the moment that's one of the main things people can be doing above and beyond healthy lifestyle, exercise, diet and sleep. You can maybe improve that a little bit with supplements while we're waiting for the first generation rejuvenation treatments to come along. Let's have a look. Oh, Andrea Maier again. Now, this is the last time I think we have in the slides, but she had lots of interesting things to talk about in her presentation, including NMN, rapamycin and AKG. I'm only going to look at the part where she talked about NAD. This is a real crucial molecule in the body. It's used in energy production between all the cells. It interacts with sirtuins. so involved in DNA repair. It's a really important molecule. NAD boosters are really popular, however you decide to take them. And the main reason I brought this up, because I think the most interesting slide at the conference was this one. Not really kind of very medical or advanced, it was just more shocking that her team, or some part of research she's involved in, they ordered 10 samples of NMN online, and only 4 out of 10 of those had more than 90% NMN in them. 4 out of 10 didn't even have half of NMN in there. So it's a real, I mean, I think everybody knows with supplements, you've got to stick with really reputable suppliers. There's an awful lot of cheap rubbish out there. Never buy supplements just on the price alone. You know, you've got to be looking preferably at GMP, good manufacturing practice, supported suppliers, and we can see why. Not only are you possibly not, you might pay half the price of a good supplier, but as we can see, you might only get half the NMN, so you're not getting any more for your money. Even worse than that, who knows what they're filling it with. There's been reports in the past showing some pretty toxic substances are topping up where the supplement is short of what you actually think you're buying. Interestingly, Andrea mentioned they are still trying to figure out, are they going to name names in the research paper? So we'll wait and see when this research is published. This might be a really great source of recommended suppliers, or they might just think it's just too risky from a legal perspective to name names in there. Okay, another popular supplement at the moment is Urolithin A. It stimulates mitophagy, so you get healthier mitochondria in the body. This was from Chris Rinch at Amazentis, so they produce MitoPure. So obviously they are promoting Urolithin A as a supplement as they're selling it, but it looks like they're taking a good approach using randomized control trials and RCTs, so they're kind of gold standard for clinical trials, which means nobody knows which supplements people are taking. It's totally randomized, it's not self-selected, so this is a good way to do trials. And they can see in these trials that for middle-aged people, certainly they were seeing good improvement in muscle and skeletal strength. Very important as people become more frail as they get older. And I think with Urolithin A, the important thing to remember is that you can take it in your diet or as supplements this way, and that most of the Urolithin A in the body, I think, is produced by your gut bacteria, but only about a third of people have the right bacteria in their gut to produce it. So most people can't produce enough Urolithin A without getting it as supplements. Then selenium and coenzyme Q10, which is a supplement been around for ages. I think it's in Ray Kurzweil's book. Transcend is one of his early recommendations, and this was being presented by Urban Alihagen from Sweden. He's an experienced cardiologist and a professor in cardiology at the University of Linköping. Again, nice long talk. One of the big slides he had up here was cardiovascular mortality. So in a big study, they were looking at people who died of cardiovascular disease at a period of time after taking supplements or not taking supplements, because this was again a randomized control trial. And you might just be able to see, so the red are people who were taking the supplements, blue are people who weren't taking supplements, and this is a survival curve, which means right at the beginning, 1 means 100%, 100% of people were alive, and over time, the number of people still alive drops off over time. Now this drops off reasonably quick because the study was using healthy elderly. Not too sure what the age range was, so maybe 60s or 70s. The drop-off wouldn't be as quick in someone who's 20 or 30. And if we look at the 10-year drop-off, we can see that after 10 years, the placebo arm, half of those people who died of cardiovascular disease are dead. Hard to say that, or let's just say it was everybody, although it's not quite everybody. Let's say half the people were dead, and of the people who were taking the supplement, 75% of people are still alive, so only 1 in 4 are dead. So you're kind of almost doubling your chance of still being alive by taking selenium and coenzyme Q10. So that was an interesting study worth more investigation. Okay, aging research. And I'll always say I'm not a biologist. I'm getting up to speed with the biology of aging as quickly as I can. So I'm sure there was a lot of very detailed discussion here. So I have just picked out 4 slides, which I thought, well, that looks interesting. It's new to me. I think it should be hopefully understandable to the club's audience. So worth having a look at this. There was Claudia Cavadas from the University of Coimbra in Portugal. Among several things she talked about was the primary cilia. So this is an organelle which actually protrudes from the cell and is mainly used in signalling and sensing. And she's been studying it and has determined that you can actually look at the shape of this one organelle which protrudes from the normal cell or a cell, and you can determine the health of the cell from its shape. So that's interesting. Not sure whether that will ever become another aging clock, but maybe when you're taking samples and in vitro studies, then this might be a handy way of being able to see whether the health of the cell is improved just by looking at the one marker which is on the outside, so maybe easier to see. There was Eleanor Rusin, who is Chief Scientific Officer at American Cell Technology. So they're a commercial stem cell banking provider, so obviously they're very interested in stem cells. She presented an interesting talk about the practicalities of stem cell banking, but also looked at some of the regenerative medicine options which you might be able to use those banked stem cells for. This was something I just hadn't come across before, was that I always imagine stem cell treatment will mainly be kind of using stem cells to create cells which have to replace ones which have died or become ill, so maybe in the heart after a heart attack, or in your muscles to combat sarcopenia. But this was actually showing this diagram. On the left you've got a mesenchymal stem cell, and rather than that just differentiating into a different type of cell and to replace it, they have found that the stem cells can actually transfer healthy mitochondria into other cells. So if this cell is degrading partly due to dysfunctional mitochondria, then it can actually become more healthy again by having stem cells next to it, not differentiating, not replacing it, but transferring healthy mitochondria over via these tunneling nanotubes. Sticking with mitochondria, we had Nuno Raimundo from the Multidisciplinary Institute of Aging in Portugal, also at the Penn State College of Medicine. I thought this was just an interesting, simple diagram, but simple, but also highlighting how nothing's simple in biology, even at this high level. Mitochondria don't just appear and disappear. Actually, with mitochondria, they have a complex life cycle where biogenesis is their creation, but they can go through fission, so they can split into 2. So you're not always just looking at a single mitochondria. It can split into 2. Now some of those then might die off via mitophagy, but then some of them might merge together again. So then you've got this kind of real loop between mitochondria forming, dying, splitting, fusing. So when you're looking at mitochondria, you can't just look at individuals. You're always going to have to look at how they're doing, kind of all of them, how all of them are doing within the cell. So it looks like it's a very dynamic situation. Then just finish on the aging research and the summit. Coming back to João Pedro de Magalhães, he maintains Drug Age, which is a database of aging-related drugs. And this is just to show how, among many other things, it is growing exponentially. So, I mean, it's been a real boost in aging research. I have another hat which I wear, which is a trustee of the British Society for Research on Aging. And lots of the people that I bump into there, they say, yeah, 10, 20 years ago, aging research was a real backwater of research. Within the biology community, people couldn't quite understand why you would even want to do it, because it just happens naturally, as people say. So why look at it? Why not look at specific diseases? As we're now all definitely learning, aging is the cause of so many diseases. Everybody saw the curves during the COVID pandemic, where the older you were exponentially more likely to die of COVID. It's the same for many diseases. But actually, so I've gone off a little bit there. But he was showing that there's an exponential growth in longevity drugs in the database. Now, the numbers on the left are not the number of drugs. These are actually the number of entries which reflect the drug in a particular animal model at a particular dosage. But I think the drugs are kind of going up similarly. There are over 1,000 distinct drugs in this database now, and only a fraction of them are actually going to end up in the clinic. I think about 2/3 of them have lifespan extending effects, which is great. They only put drugs in there which act at a low enough level that it affects multiple aspects of aging. They're not looking at drugs on specific diseases or specific disease animal models, where the animal has been genetically modified to reflect a certain disease. We're looking only at longevity drugs, but most of those in the database do have a positive effect on lifespan, and you only need a small fraction of those to turn into a clinical drug to have a really big impact on everybody in the world. And you can see it's growing. Maybe in 10 years time we're going to have thousands more drugs to have to do trials with. Okay, so in summary, definitely interesting conference. There are advances presented in all areas. You've got the aging research, which is so important. There's a lot of interesting things going on, lots of biotechnology firms setting up. We've got first generation rejuvenation treatments such as senolytics going into clinical trials, but these are just first generation ones. At best, we're going to knock off 1 or 2 years off your biological age, maybe 3 or 4. But as Aubrey de Grey's longevity escape velocity plan is, if we can do that, do senolytics one day, knock off each hallmark of aging, you've done 10 rounds of that 10 years later. The next time you come round to say senolytics, we want those to be working a lot better, and they're only going to work a lot better if we understand the biology of aging even better. So great to see lots of aging research continuing and advancing. Got more aging clocks on the way. As I said, this is really important, not just for you individually to track your own health and your biological age, but so that the clinical trials of rejuvenation treatments can be assessed quicker, within months or years of people taking the treatments, not having to wait decades to check whether there was a real impact on those people's health. There's a real push into preventative medicine, which is, there was a economic study a couple of years ago by Andrew somebody, and I always forget his name, apologies, economist in the UK, written with David Sinclair and somebody else in the UK, and it would just show the multi-trillion-dollar benefit to the US economy on its own by extending a healthy lifespan by 1 year. The return on investment is huge. It's a real shame that governments aren't pushing more money into preventative medicine and aging research and aging treatments. And I think that kind of sums up though the interventions. As I said, this conference was still just the supplement, but we know there are a lot of things on the way, which hopefully I will produce some videos about in the near future. Thank you, everybody.